Hey guys, and welcome back to another Python tutorial video. Today we're going to be going over Python object-oriented programming, or also known as OOP. So OOP is object-oriented programming, and this is a very, very important concept. If you're not familiar with this in programming, I'm going to try to explain it in a way that will make sense to you. So object-oriented programming is the ability to represent an object in virtual space. That's going to be my personal definition. This is a way to organize code. It's also a way to work with defining certain things. For example, if I have a button on a screen for a mobile app, right? There's a lot of properties to that button. We need to know the clickable area of the button. Where are we allowed to click? We need to know the text inside of the button. We need to know what color the button is. We need to know what is the shape of the actual button. There is a lot of detail that goes into that button. Well, it would be a pain if we had to type out the code every single time we wanted to create a button of some kind, right? Well, instead, what we do as programmers is we say, okay, we know we have this one thing that we want to create over and over and over again. So we're going to create something that can be called over and over again. So this is what we're going to do. We're going to start by creating a class, right? So we're going to create a class, and we're going to call it Apple. Right, so we have the Apple class. We're going to start by doing this, which is init. And then we put this here. And right after this, we put, well, first, let me make sure I put this here. And on top of an apple, we would like to put parameters. So for example, when we define an apple, I know this seems like a lot all in one sitting. I don't want this to be really crazy for you guys. It just, you have to memorize a lot of this stuff. It just is what it is. You kind of have to just go with it. A class is the starting point of how we're going to define our object. So this is like the name of the object. You have your apple, right? And then you have what is called a constructor. So the constructor is the starting point for your object, right? We're just defining what an apple would be in virtual space. So let's figure out what the characteristics of an apple could be. We have the name of the apple, which we're going to default to just quotes right here, which is nothing. In fact, we're going to put none in here. Whenever you do an equal sign inside of here, it just sets a default. Same thing goes for functions and other things. This works just like a function. And what we'll do is add a color. So we have a color. Let's say the default is red, right? So we have red apples. But also an important part is that we put self. So self says, okay, this is a part of the apple. This is the apple, right? Another thing we have to do is do self dot name equals name, right? And self dot color equals color. And let me explain what this is. So when we have these variables here, right? These parameters, which is required to make an object. Now remember, just follow along with me here, because I won't be able to show application until we're done. But just know that the constructor is how we build it. So if you ever want to make a characteristic for an apple, you just have to do self dot and whatever it may be. Let's say we wanted the count for an apple, right? Well, let's say we just wanted 1 for the count of the apple, but we don't want it to change, right? We would like it to just stay the same, but it can still be modified, right? We don't want it in the constructor, because in the constructor, you could change the count of the apple, but the apple only equals 1, right? So we want to keep that the same. So another thing that is very handy is adding functions to your object. So let's say we wanted to allow our apple to roll. So we're going to have a function called roll. What we can do is type this in. We can type in print and say the self.name, so we want name, actually we have to call self inside of this. Anytime you make a function, make sure to call self. So self.name plus, and then we're going to put apple I guess we could do rolled. We'll do rolled. Rolled. Okay, so this is a really quick application. I know this is a lot and a lot amount of time, but I'm going to go back and explain this again. Oh, but not that way. So we're going to stop that. Name. All right. All right. And then we're going to create a variable. We're going to call it var equals apple. And we're going to have it with the name of red. Oh, we're going to have red. Actually, we'll call it Granny Smith. Like the Granny Smith apple, for example. And we'll have the color green. We're going to have the color green. So now we have this variable, right? We have this variable, which we can actually call apple. It can be named anything, remember? Variables can be named anything. But in this case, we're just going to call it apple. And what we can do is actually say, we want apple.roll. And what does apple.roll do? Well, it should just print this out. In fact, let me make sure there's a return here. All right, if we run it, the Granny Smith apple rolled. So why does this work? Why did it actually come out with Granny Smith? So I'm going to start from the beginning. So we created an object through a class, right? We called it a class called apple. And apple has a constructor. And a constructor is how we create the object. Init stands for initialization, which is where we get like everything from here. We get all the variable names, we get everything. We have a self.name, we have a self.color, we have a .count1. So why does this work? I'm going to kind of give a picture of what we just created, right? I'm going to put this here, put this here. So I'm going to close this. I'm going to close this. I'm just going to have this white canvas. So on the left side here, we've created a apple class, which is just an apple object with a constructor that defines a name. So we have a name for our apple. a color, and a count. But we can only input name and color. So it also has a function where it prints out a roll. So we can roll. So what we've actually done is just created an object, which can actually just be a circle. We'll make a circle real quick. And this is going to represent our object for an apple. And we're going to choose the color white for the text. We've given the apple a name. We've given the apple a color. And we've given it a count. And by default, the count is 1. Well, down below, as you can see here, we've created Granny Smith as the name. So the name equals Granny Smith. Let's move this over. And the color is green. So we can call all these attributes, right? But what actually is this? What we've created is a holding point for what we call an apple. So our version of an apple is something that has a name, something that has a color, and something that has a count. So could we do the same thing with a button? Well, of course you can. You can go ahead and create boundaries, the length, the width, and the height of, or the length and width of an actual, maybe it could be a rounded rectangle, or maybe just a square button. It could be anything. And you just go ahead and define all of the things required for a button. It's very, very cool how object-oriented works. So I hope this is a pretty easy tutorial so far. I'm going to get into another advanced topic in a moment. Well, what if we wanted to have something that inherits from an apple, right? So what can inherit attributes from an apple? Well, we know that an apple is a fruit. We also know that apples have seeds, right? Well, let's say we wanted to add some functionality to our apple. So let me do this. We're going to make another class, and we're going to call this fruit. Okay? And we're going to have an init. And remember, you have to put self because it's an object. And an init has a name, which by default will set to fruit. It has a color, which we'll keep blank. And we'll go ahead and define these here. We're going to do name equals name, self.color equals color, self.count equals 1, and self.taste. We're going to add a different taste, and we're going to put it as sweet. So what if we wanted a function where we know that all fruit can roll in a sense, right? We can make all fruit roll. So we're going to do roll. We're going to call self because remember it's still an object. So we're creating a fruit object, right? And this time we're going to put a return and print statement. And this time it's going to be the blank, the name. Oh, we're also going to do a type. We're going to try type equals, and we're going to do none. So it has no type. The name of the fruit, and this time we're going to have the type self dot type, and then we do rolled, right? So now we have the name of whatever the fruit is and the type, which is by default none. Well, now let's go ahead and make a fruit object, shall we? So we're going to make a fruit object. I'm going to name this variable fruit for demonstration. And we have fruit. And remember, what are the requirements to make a fruit? We need the name and we need a color. But by default, if we don't put anything in, it'll be fruit and a random color. So let's have a, we'll name the fruit apple. Or we'll call it Granny Smith apple. Or Granny Smith, and then we're going to do color equals green. Same input, right? We're going to have the same input. This time we're going to do fruit dot roll. Now let's see what happens after we run it. Oh, we got to do one thing. So if we have a type, we're going to need to make sure that it's a string. Because they can't do things all by themselves. So if we don't have a type, it just says the Granny Smith rolled. Well, we set the name to Granny Smith, but is this a Granny Smith? Well, technically it's just a fruit, right? We can't say that it's an apple because it has no type. So let's give it a type, shall we? So we'll do fruit.type and equals apple. So let's run this again. The Granny Smith apple rolled. Of course, there's a little bit of a typo here because we need to do this. We go ahead and put this in here. And this is not the best way to format your strings, by the way, if you guys are familiar. But now we have the lowercase one, which is what this was right here, right? We have the lowercase apple, but we'll go ahead and put this right here, capital Apple. So then you can see that they're going to come out the same. So these are exactly the same, but one is more specific than the other. This is an apple, which is still a fruit, and this is just a regular fruit. So this is not an apple. An apple is its own thing, and a fruit is its own thing. So how do we fix this? How would we fix this? The way that we can fix this is something called inheritance. Objects can inherit things from other classes. So for example, the child of a fruit would be an apple, right? Because inside of the category of fruit is an apple. So let's type in fruit inside of here, right? Now, if we go ahead and run this, you're going to notice something happened here, right? So it looks exactly the same, but there's no error for when we put this in here, right? So believe it or not, an apple is inheriting a fruit. And I know this sounds very crazy, but what I'm going to do is we're going to do fruit dot init, and then we're going to put in name and color. But we're going to do name equals name and color equals color. I think this will work. Let's try it out. And this time we're going to take name and color out. Oh, do I need to do this? I think I need to do that. Let me double check. Apple has no attribute name. Oh, it's because it's not set. Okay, so we'll just take all of this out right here. Let's see what happens. Positional, oh, self. Run it. Okay, so here we go. So now here's where things get interesting. So as you can see, when we did this, the fruit dot in itself, right? We have the input for a name and we have the input for a color. But when we did fruit dot init, which is initialization, which means this one overwrote this one, right? We're starting to get the fruit apple rolled. But that's not what we had before, right? We just had a Granny Smith, which was the name, and the color green. Well, in our original, we had the self.name, right? Well, now we have to set the names of each of these things. We have to be able to overwrite this. So how are we going to do this, right? We'll do name equals none, which is none, and color equals red. So we're going to take this out, and this is by default, it's required. Oh. Color, hold up, let's do this again. Name equals none, and color equals red. Fruit has a color, there we go. Okay, let's run it. The none apple rolled. So now we actually have a name specified, right? But the default we had to do from here. But we can actually just keep this, and this should be fine. And it says the fruit apple rolled. But that's because by default, the name fruit is the default for a fruit. So what we have to do is we can actually take this out now. Oh, well, what we can do is this. So self.name equals name. We still need to set these, right? So we do self.color equals color. And we should get the same result. So what we did was we took the input from here rather than having the default from fruit. So this way we've actually created a fruit object. And we can tell that things are a little different, right? So if I come over here and I do apple.type, well, actually we'll do it inside of here. We'll do it inside of here. If I did self.type, see how it comes up automatically in Visual Studio Code? Well, we didn't create a type. We only created it in fruit, right? Well, by default, we've actually created our own type, and it's called apple. And now, if we make sure that we run it, and we run it all the way through, we should get this result. And this makes sense, right? Well, if I took away the defaults for the Granny Smith and the green on the fruit, and the type was not apple, we just run it, and the fruit rolled. That's all we have. We only have the fruit rolled. We have nothing else. We don't have anything interesting going on. But we've taken the fruit and all of these variables, and we've attached it to the apple here. So know that that is how a object works, is that it has inheritance, and it can actually give other functions. So let's give it another function, shall we? What's another thing that a fruit can do? Well, we can give it the ability to grow. So we're going to do self, and we're going to do a print the fruit grew. and we're going to return. So what if we do, instead of apple roll, we do apple dot, and we type in grow. Isn't that weird how it auto-completed for grow? And now if we do this, we do fruit dot grow, we have the output for both. But we did not create a function for grow here, right, on apple. This is a pretty big concept. This is a really hard concept to understand. So I completely understand if this was a lot. But all I'm trying to show is that functions can carry on to other things. So if we took the code just from right here, we have a constructor like we've created before. We have variables, so aspects of our object. We have more variables, a list of variables here. We have functions that we created that work with the variables here. And then we have another object that inherits from a fruit and can do all the things that a fruit can do. And we have a constructor with our own variables. We have the constructor from the original fruit. We have the variables here, and we have a function, which is its own function. So I hope you guys thought this was insightful and this helped you out. There is a lot. I'm not a professional by any means, and I hope that you at least got something from this that you can use to fiddle around with these and kind of play around. You can't really break code like this. It's good to experiment early on and kind of figure out how things work and visualize. I use paint.net to kind of visualize a lot of the stuff that I do. So definitely go ahead and try out making your own objects, and just starting with maybe just the fruit, or the fruit over here, right? Or just creating like an apple or something. Find something in the world that you'd like to recreate, and I challenge you to do this, and make variables for every aspect of it, and make all those variables for it. Anyways, I hope this video was good and it helped you out. Thank you so much for watching. Hope you enjoyed, and I will see you guys in the next video. See ya.